Okay, so then the earth revolving around the sun is periodic. It's repeating itself at regular intervals of time, sun, and this is earth. And so then anything which repeats at regular interval of time is known as periodic motion. Oscillatory motion is one where it moves to and fro about its mean position, where there's a restoring force which comes into play. That's known as an oscillatory motion. Okay, so you understood the basic thing of periodic motion and oscillatory motion. Now let's talk about the periodic function. A periodic function, lesson starts here, is the one which repeats itself at regular intervals of argument. We don't use the word time, regular intervals of argument. Argument is the angle it makes with the positive direction of x-axis. Supposing it starts here and comes here with the same theta, it comes and ends here, then and repeats itself. That's known as regular intervals of argument. Is also periodic function. Periodic function can be represented by, say, a simple example of periodic function is f of t, which is sine of omega t, which is a sine function. As you know, you can put a sine graph 0, pi by 2, pi at 3 pi by 2 and at 2 pi, where sine 0 is 0. Sine 90 is 1. So the plus 1 minus 1. Sine 90 is 1. Sine 180 is 0. Sine 270 is minus 1. Yeah, can you see it corresponds to, and like this. So sine omega t, and a g of t which can be also represented as cos omega t. A cos function is also a periodic function which is repeating itself as also moving to and fro about its mean position. So then cos function is like plus 1 and minus 1. You know, 0, this pi by 2, this pi 3 pi by 2 and a 2 pi. Cos 0 is 1, cos 90 is 0, cos 180 is minus 1, cos 270 is 0. And goes on like this. So this g of t and f of t and g of t are periodic functions. They are also classified as a harmonic function. Harmonic function. Any periodic function which can be depicted in the form of sine and cos graph are known as harmonic function. The fact that there is a restoring force, its mean position is there, that all makes it harmonic. Whereas you see this is non-harmonic function, but it's periodic. It's repeating itself. This is an example of a DC current. A direct current will flow like this. So this is a periodic function, but is non-harmonic because you cannot represent it as a sine graph, and it's not moving about to and fro about its mean position. Restoring force is not there, so it's non-harmonic. Whereas an alternative current graph will be like this. Best example of a harmonic function. A periodic function which is harmonic, a periodic function which is non-harmonic is these two examples. Okay, so then let's go to next. I want to do a numerical which is, on an average, a heart beats 75 times in a minute. So it's 75 times in 60 seconds. In 1 second, how many times it's beating? So you know that it will beat 60, x is equal to 75. So x is equal to 75 by 60. 5, it's 1.25. The answer for this is 1.25. I'm copying the answer. So then that will be x, which is the beating per second. The number of oscillations per second is nothing but frequency, correct? Yes. So therefore this is a frequency. What we have got is the frequency which is 1.25 hertz. Or SI unit can also be per second, 1.25 per second, because reciprocal of time period is what is frequency. So thus you get the number of oscillations per second. So they are asking for time period. They are asking for frequency which is nothing but this. They are asking for time period which is a reciprocal of frequency. 1 by 1.25 which is 0.8 seconds. That will be the time period. Okay, that's the first sum. The second sum is a sine omega t plus a cos omega t. Is this periodic? If they ask you if this is periodic, this will definitely be harmonic. Yes. Because if any sine functions and cos functions will always be harmonic. But they want us to prove that it is periodic. And are they asking harmonic? They have not asked harmonic, just periodic. So then therefore you should mug up this, where I have to multiply and divide by root 2. So when you have something like this, you have to multiply and divide by root 2. A sin omega t plus cos omega t. Take only this 1 by root 2 inside. It's 1 by root 2 into sin omega t plus 1 by root 2 into cos omega t. You can write this root 2 as cos 45 sin omega t plus sin 45 cos omega t. So that this of the form sin A cos B plus cos A sin B, which is sin A plus B, which is sin omega t plus 45, which is pi by 4. I told you 45 degrees pi by 4. So we have now got it into one single sine function. This is okay. You can have a root 2 which refers to the amplitude. Always this refers to the Amplitude. Amplitude means for a sine function, what is this maximum amplitude? That's root 2 here, correct? So you understand what does the root 2 stands for? So you understood what is the root 2 stands for? It's for the maximum amplitude, correct? And next question is what is omega stands for? Omega is the angular velocity, which it is 2 pi by capital T. Yeah, and what is this pi by 4 stands for? Phase difference. Pi by 4 stands for the phase difference. Okay, so this is something you need to know. So then therefore this is a complete sine graph. One single sine graph will be periodic, definitely. So if you have two different sine and cos, if you have doubts over whether it can be periodic, try to convert it into one sine graph or one cos graph. Are you clear?
Yes.
Okay, next, let's go to next. There's so many questions like that. Next is, normally your teachers would also do this. Okay, I'm going to teach you something. For the same first sum, we have a sin omega t plus a cos omega t. In this we'll multiply and divide by root 2 is what I said. You can also simply write an r cos theta and an r sin theta. Instead of multiply and divide by root 2, I'm taking the 1 by root 2 inside. Instead of this 1 by root 2, 1 by root 2, you can also write as r cos theta and r sin theta. So this, if you take the r out, you have a cos theta sin omega t plus sin theta cos omega t, which is r into sin a cos b plus cos a sin b, which is nothing but sin of omega t plus theta. Therefore, you manage to convert a sin omega t plus a cos omega t into one single sine function where r stands for the maximum resultant amplitude. Resultant amplitude. Omega stands for, okay, normally they won't write as r cos theta, they'll write it as r cos phi. R cos phi and an r sin phi. R cos phi and an r sin phi. So you'll get this like this, where phi will be your phase difference. And omega is your angular velocity. You can also prove like this. It's not necessary you have to multiply and divide by a root 2, but that is more simpler. And taking it and writing it like this is more simpler, but your teachers might try to do it as multiplying. They'll introduce a r cos theta and an r cos phi and an r sin phi, and they would take it like this. This is for just for your knowledge. For the numerical, it's enough to do it by multiplying divide by root 2. So next is we ask you sum number 2 in Aurora, a sin omega t plus a cos 2 omega t plus a sin 4 omega t. Is this periodic? So then in here you can't multiply and divide by root 2 because there are no two functions on it. There you had just two functions. You could multiply and that too a sin and a cos. Conveniently you could multiply and divide by root 2, or you could multiply and divide by, we could just take it as r cos phi and r sin phi. Try to avoid this. Try to write multiply and divide by root 2 in numericals. So you can't do that technique here. So what you should do is, what is omega from here? Omega itself is 2 pi by capital T. Take this omega. The coefficients of small t is your omega here, and that's 2 pi by capital T. And you know exclusively sine function is definitely periodic. And it's also harmonic, and it repeats itself at a time period of 2 pi by omega. It will repeat itself at t is equal to 2 pi by omega. Now come here. What is the coefficient of t here? For this function, 2 omega. So 2 omega is equal to 2 pi by capital T. 2 and 2 get cancelled. So time period here is pi by omega. So to come here, it's 4 omega is equal to 2 pi by capital T. So this time period here is equal to 2 omega by pi by 2 omega. T is equal to pi by 2 omega. Therefore, if this time period is T, this time period will be T dash, which is T by 2. This time period will be T double dash, which is T by 4.
Yes.
Can you compare these three time periods?
Yes.
And you understand that the time period for this is T dash and this is T double dash. And comparing it with the first T, you know this is half of this and it's 1/4 of this. So thus, you know, the LCM of T, a T by 2 and a T by 4 will be T. Least common multiple for all this. So all these functions will repeat itself at a time period of T, which is T is equal to 2 pi by omega. A small example that I can give you is there are 3 bells. One is ringing at this time period, another is ringing at this time period, this time period. Do you know that supposing this is 4 This is 4 seconds. This is going to half of it 2 seconds. This is 1/4 of it, which is in 1 second. All of them together will ring at 4 seconds. And yeah, so that's what it is. Okay, so that it's repeating itself at 4 seconds together. So all this is plus plus plus. So together they are going to be repeating itself at a time period of 2 pi by omega. Hence they are periodic. Are you clear?
Yes.
Okay, next is some which is e to the power minus omega t. You know, exponential function, the graph itself is like this. It is not repeating. It's non-periodic. That's all. You just write non-periodic. No need to proceed also. Similarly, log function, the graph is not periodic. Log functions are non-periodic functions. It's a non-periodic function. It's not going to repeat itself. Okay, so that's about that. Next. Okay, here comes the next part of the lesson. So for this introduction, next part of the lesson is, you all know that we have learned about simple harmonic motion. SHM is a simple harmonic motion. In a simple harmonic motion, the best example is, you know, the spring that we have learnt, which is going to, if you put it like this, if you extend it like this, there will be restoring forces. So a simple harmonic motion is one where there is a restoring force. Where F is proportional to X, F is equal to minus K into X. Wherever you can write as minus K into X. An oscillatory motion, any oscillatory motion therefore is simple harmonic. Correct? So you know F is equal to minus K into X. You also know F is equal to M into A. So you can equate MA is equal to minus K into X. Therefore you can write A is equal to minus K by M into X. You should know that omega itself is, omega square itself is K by, omega itself is root of, omega square is K by M. Omega itself is root of K by M. You should memorize this. Omega is angular velocity. Omega square is K by M. So therefore you can write it as A is equal to, sorry, here it is X. So minus omega square X. Can you see, whenever the acceleration is proportional to displacement in the opposite direction, such a motion is called simple harmonic motion. Whenever you can bring it in this format, it will be simple harmonic. Correct? So then, if they ask you to write a differential equation for this, you know that velocity is dx by dt. And acceleration is d square x by dt square. By simply changing this as d square x by dt square is equal to minus omega square x, and a d square x by dt square plus omega square x is equal to 0. We have converted this into a differential equation. It's very, very simple. Okay. This is one way of doing. I'll teach you another way of doing, which is like, you should know that the displacement x is always a cos omega t plus phi naught. In this lesson where we are going to learn, I'll tell you how this came a little later now. But remember this, x is position vector, or the displacement is always a, which is amplitude, cos omega t plus phi naught. Fix that. Okay, now you differentiate this, which is dx by dt, which will give you velocity. Which is, as you know, a differentiation of, differentiation of a sine theta is cos theta. A differentiation of cos theta is minus sine theta. And there's a chain rule where you have to do inner differentiation. I'll just teach you that. So differentiation of this is minus a sine omega t plus phi naught. You differentiated cos theta, you got a minus sine theta. Then you have to do inner differentiation. What is inside? Inner differentiation. Inner differentiation is differentiate what is inside, which is omega t plus phi naught, where with respect to t you're differentiating. So omega t alone can be, this is a constant. The differentiation of constant is 0. So the omega t on differentiation will become omega into dt by dt, therefore into omega. Therefore you should write it as minus a omega sine omega t plus phi naught will be the velocity, which is dx by dt. Okay, so then therefore straight away you should be able to write. Okay, you should, without even thinking about all this, you should know that the differentiation of x, which is v is equal to dx by dt, itself is minus a omega sine omega t plus phi naught. Now you want to get acceleration, differentiate it again, d square x by dt square. When you differentiate sine, it will be cos. And inner differentiation another one omega. So minus a omega square cos omega t plus phi naught. Can you see that a cos omega t plus phi naught can be brought in from here and written as x?
Yes.
So then a is equal to minus omega square x.
Okay.
Yeah? Or d square x by dt square is equal to minus omega square. So d square x by dt square plus omega square x is equal to 0. This is another way of arriving at a differential equation. You can do it either this way or by differentiating you can do it this way. Whichever way your teachers wants you can give it. Okay, so then that's about it. Next is to find the time period. Okay, you know that let's see if a function is repeating itself. Okay, so supposing the function is x is equal to a cos omega t plus phi naught is the function. To see if it's going to repeat itself at every regular interval time, you know, for a sine or a cos function, you take t is equal to 2 pi by omega. It is repeating itself as 2 pi by omega. So let's add this t with the 2 pi by omega. That is, I'm adding a into cos of omega into t plus capital T. To see if it's going to repeat. I don't know if it's going to repeat. We're going to check that. So x is equal to a into cos of omega into t plus 2 pi by omega plus phi naught. Now I'm going to bring the omega inside. So x is equal to a into omega t plus omega get cancelled 2 pi plus phi, correct? They call it phi naught, no? Phi naught. So can we write a 2 pi first? A 2 pi plus omega t plus phi naught. Why do I write 2 pi? Because I taught you in the introduction, when it's 2 pi plus means it is in the first quadrant. And 2 pi is an even integral. Yes. All will be positive. An even integral means cos will remain to be cos. So it's x is equal to a cos omega t plus phi naught. Where you started, you ended up getting the same x. So that confirms that even after you put adding a capital T, which is a 2 pi by omega, your answer remains the same. Therefore, it is periodic in nature. That's how you prove it's periodic, correct? Okay. So hence proved periodic. Hence proved it's periodic. But now, with the time period being t is equal to 2 pi by omega, you already know omega is equal to root of k by m. Yes. Correct? So t is equal to 2 pi into root of k by m. So t is equal to 2 pi into root of m by k. Mass by a spring constant. Inertial factor by spring factor, they'll say like that. But t is equal to 2 pi into root of m by k is the time period formula. Are you clear? Next, what should I teach you? Is okay, how did you get that a cos omega t, the representation? I told you here to assume like this. Yes. How did you get that? The question for that is, write velocity, write displacement in simple harmonic motion. Write expression of a position vector or displacement. Position vector or displacement in a simple harmonic motion. Okay, in simple harmonic motion. Whatever the question is. Okay, so you should rotational motion. Take this. Supposing there is a point A here, which is already at an angle of phi naught from the x-axis, which is called the argument. Okay, or if no, let's not say argument. It says phi naught is the phase difference is what we say. So now from here, it is moving to this position. Let's say it's going to P, making an angle omega t. From initial angle is phi naught with x-axis. It is moving to P, which is an angle omega t, with angle between these two. Can you see therefore the total angle is omega t plus phi naught? Yes. The total angle itself is omega t plus phi naught? Yes. Supposing this point is getting projected on x-axis. This will be my position vector. Are you clear? This will be, this green color horizontal line will be my x from the origin. It's going to, see, as it rotates, it's going to move to and fro like that. It's going, every position, it will come like this. You project it on x-axis, okay? So then therefore, you project this point on x-axis to get the exact displacement from the mean position, which is the origin. You have to project it on x-axis. This is your displacement. To find this, you know, the radius is nothing but the amplitude. The radius here is nothing but amplitude, correct? Yes. This is something else, okay? This A is amplitude A. So then, you know, taking this right triangle, you can write cos of omega t plus phi naught is equal to adjacent by hypotenuse, which is A. Therefore, x is equal to A cos omega t plus phi naught. This is how we get an expression for the displacement depicted on a rotational motion. With this, when you differentiate, you get velocity. When you differentiate again, you get acceleration. That you know. So now let's do a velocity. Let's do a velocity in simple harmonic motion. Okay, so velocity, you know, when you differentiate this itself, you will get velocity, which is minus A omega sin omega t plus phi naught. But I have to get it in terms of diagram. To get it in diagram is very complex. Okay, let's try to do it. Draw a circular motion. Supposing the particle is as usual A here. The problem with the A is amplitude is also A, so it's okay. A here, and it's moving to P here. This angle is phi naught. This angle is omega t, and the whole angle becomes omega t plus phi naught. But we are doing velocity here. Okay, so then 1 second. I'll just draw this P closer. Let me draw the point A here. Yeah, and it's moved here. Let this be my point P. This is phi naught, this is omega t, and this whole thing is omega t plus phi naught. I'm going to draw a velocity vector which is tangential. You all know it's tangential. Just draw it, extend it. This is the velocity vector. And linear velocity is r times angular velocity, where r itself is amplitude A, which is radius A, into angular velocity. Correct? V is A omega. This is linear velocity. Now you're going to draw a vertical line like this. Yeah? If this is omega t plus phi naught, if this whole angle is omega t plus phi naught, this angle will also be omega t plus phi naught. And you have to draw a horizontal line like this. Because if this is going to be the velocity vector from the mean position, because it's oscillating to and fro, but v of t. This is also v of t. Can you see this is also v of t? Parallelly? Can you imagine this is also v of t? Yeah? So then can you, if you want to find this v of t, which is this in this direction. Velocity is towards the mean position in oscillation. So you want to find this, can you take this right triangle and write sin omega t plus phi naught will be v of t, which is actually directed towards the negative, towards the center, which is negative x direction. In this case, v of t is in this direction, by the hypotenuse, and the hypotenuse itself is nothing but A omega, because the hypotenuse happens to be here, which is nothing but your A omega. Do you understand? In this right triangle, the hypotenuse is linear velocity is A omega. So then V of t therefore is minus A omega sin omega t plus phi naught. Are you clear? So this is what we got by differentiating also. But so simple to differentiate, whereas to depict it in the diagram has been very, very difficult. Correct? Diagrammatic representation was little tough. Okay, that's about velocity. Supposing you want to get acceleration in simple harmonic motion, in the rotational motion. So with regard to acceleration, you can always differentiate this and write A of t is equal to minus A omega square cos omega t plus phi naught. So simple. But if they ask you to write it, depict it as a diagram only, we have an issue, correct? So then in that case, if they ask you, you know that this is going to be the initial point A, it's phi naught, it's going to move through another point P through a distance omega t. You all know that acceleration, you have studied in the first volume, the rotational motion, the acceleration is always pointed towards the center, and A is equal to V square by R. And linear velocity is R times angular velocity, R square omega square by R. R and R get cancelled. A is equal to R omega square. Here R itself is capital A, which is the amplitude, which is radius. So then this is A omega square. That's the radius. Okay, and the acceleration for this, the acceleration is always pointed towards the again center. So then therefore it's going to be here. Correct? And if this is, can you see, if this is omega t plus phi naught, yeah? This will be omega t plus phi naught, this angle. Yeah, but you want answer in terms of sine, right? So we can write this angle. If this is, okay, this will be 90 minus. 90 minus omega t minus phi naught, correct?
Yes.
So I want opposite side, which is acceleration. A of t is the opposite side. So I would write sine of omega t. Okay, okay, we'll do one thing. 1 second, hold on. So let me continue. This is interior alternate. If this is going to be omega t plus phi naught, this is also going to be omega t plus phi naught. Taking this triangle, we can write cos omega t plus phi naught, correct? Cos omega t plus phi naught will be adjacent, which is a of t, by hypotenuse. What is hypotenuse in terms of acceleration? It's a omega square. A omega square. We just found that. So a of t therefore is a omega square cos omega t plus phi naught, again directed towards the center, so you should have a negative sign. So that's exactly what you will get when you differentiate this also.
Yes.
So that is about depicting in case they ask you. They don't generally ask this at all.
Yes.
Okay, but having said that, this has to be continued. Whether you differentiate it, you can get this answer by just simply writing x is equal to a cos omega t plus phi naught. So thus differentiating this, you get v is equal to a omega sin omega minus a omega sin omega t plus phi naught. Then again differentiating it, you get minus a omega square cos omega t plus phi naught. You can simply differentiate and get this also. Okay, so you can write this. Now you know minus a omega square cos omega t plus phi naught can be written as root of 1 minus cos omega t plus phi naught. Yeah, that's all. They've left it like that. Okay, they've not proceeded. Okay, they've not proceeded. But take the acceleration part. Just take this. So take the velocity part. Velocity is equal to minus a omega sin omega t plus phi naught is there, right? You can take this and write it as root of 1 minus cos square omega t plus phi naught. And v is equal to minus a omega root of 1 minus cos omega t plus phi naught. Do you remember first one? Adjacent by hypotenuse, which is x by a. You know from the first diagram, it's x square by a square. So v is equal to minus a omega root of a square minus x square by a. A and a get cancelled. Thus the velocity itself is minus omega root of a square minus x square. You take the velocity and write it as sin as 1 minus cos square and substitute like this. You get without sin and cos. Okay, now we are going to do a case study. The case study is when x is equal to 0. What is meaning x is equal to 0? At mean position. The velocity will be maximum. It will be minus omega a. And x is equal to plus or minus a, which is the extreme positions. You will get velocity to be 0. Thus you can conclude that this is the maximum velocity minus omega a, and the velocity at the extreme position is always 0 if they ask you to conclude this. So you have to start with writing from here. Differentiate and go like this and proceed like this. So depending on what question they are asking, you have to proceed in the right direction. Okay. So next that what I taught you is about the phase relationship between displacement, velocity and acceleration. Okay. So, so I'll just do a graph which is a displacement time graph. This is a xt graph, displacement time graph. And you know that you are representing, okay, let me give some space in here. You represent displacement as, in this lesson, a cos omega t plus phi naught. You know this is the way we are representing position as, okay. So let's forget about the phi naught. Just for an instant, forget about the phi naught. So let's consider that x is equal to a cos omega t, the normal cos graph. X is equal to a cos omega t. You know that I can write it as x is equal to a cos omega t. I can write, if I differentiate this, I'll get velocity.
Yes.
Which will be minus a omega sin omega t, which you already know, correct?
Yes.
But I want to get answers in terms of cos only. I don't want to write answers in terms of sin. So how do I write this as cos? Okay, you know that if I write cos 90 plus, cos 90 plus theta, the cos will become, cos 90 plus theta If I write it as cos 90 plus theta, the answer will become a sin theta. And also the question is about cos, so the answer will become minus sin theta.
Okay.
Because the second quadrant, the question is cos, the answer will be negative. All school taught your children. It's not about the answer, it's about the question. The question is cos theta. Okay, so we can write this to avoid the negative sign. And to get the answer in terms of cos, I can write it as cos 90 plus some phi. Some 90 plus some phi. With an a omega, let it be here. So you know this is an odd integral. The cos will become sin phi. And then because it's second quadrant, the answer will be sin phi. Correct? Or a sin omega t. So not phi, omega t. You can write the same thing using, 90 plus omega t. I'm sorry guys, not phi, it is omega t. The angle should not change. I can write it as cos 90 plus omega t. Because the negative sign will also be taken into account. Because cos 90 minus sign.
Yes.
And a omega can be written here. Are you clear? So you can write it like this. From that you know a omega cos omega t plus pi by 2 shows that this phase difference is pi by 2 here. The phi naught omega t plus phi will be there. No, that is nothing but pi by 2.
Okay.
Correct? Let's do acceleration. Acceleration is dv by dt, which you know you can differentiate this, you get it, correct? Which is minus a omega square sine cos omega t. Differentiate sin omega t is cos omega t, correct? But now you want to write this in terms of cos, it's already in terms of cos, but I don't want the negative sign. Supposing I don't want the negative sign. So I have a omega square which can be as it is. I want to avoid the negative sign. Cos has to remain cos. Then I can't put 90 plus or 90 minus 270 plus 270. Odd integral record. It has to be even integral. I have to write it in terms of even integral. Even integral is pi 180.
Yes.
I can write it as cos pi plus omega t. If I write it as pi plus omega t, it will be in the third quadrant. And it will become negative. Cos will remain cos. And the answer will be negative. So it suits it. So I have to write as cos pi plus omega t. Are you clear?
Yes.
Yeah. So then therefore you can write as cos pi plus omega t, or in other words a omega square cos omega t plus pi, from which you know the phase difference here is phi naught. Is pi radian, 180 degree. So if you start with a cos displacement graph is like this. Where what is the phase? It's a zero phase. The velocity becomes pi by 2 ahead. Plus pi by 2. The velocity is ahead by pi by 2.
Yes.
The acceleration is even ahead by another pi by 2, which is, it becomes pi. Purida? So I'm going to do a graph here, which is an xt graph. Okay, and you know that this x is equal to a cos omega t. X is equal to a cos omega t at 0, at a time t is equal to 0. X will be 0 only. At a time t is equal to, okay, let's write, this is, in terms of radians also I'll write, 0 to capital T is the time period. This will be exactly half, which is t by 2. This will be t by 4. This will be 3t by 4. In terms of radians, you know, 0, this is 2 pi, this is pi by 2, and this is 3 pi by 2. Both time period and radians have written. So if at a time t or at a radians of 0, omega is radians by time period, right? So omega cos 0 is, but cos 0 is 1. Cos 0, omega becomes 0 at a time 0, or in radians is 0. Radians, or this is seconds. Correct?
Yes.
Radians is 0, it will become cos 0, and x will become equal to a.
Yes.
And let's write a plus a here and a minus a here. Are you clear? The graph goes from, okay, let me write a plus a in a color and a minus a here. And our cos 0, it is plus
1.
a.
Yes.
And then as cos 90 is 0. Cos pi, cos 180 is minus a.
Yes.
Cos 180 is minus 1. When you put minus 1, x becomes minus a. Can you imagine?
Yes.
Cos 270 is 0.
0.
Cos 2 pi is 1, so it's a. So between plus a and minus a, the graph keeps oscillating. Can you see? This is xt graph. I have to do velocity time graph next. Just extend this. The same time period and same radiance is going to continue. It's going to be a velocity time graph. Okay. In velocity, you know the formula for velocity is, what was the formula we got for velocity? You got the formula to be
X is equal to
minus a omega sin omega t. Correct? So V is equal to minus a omega sin omega t. So at a time, at omega is equal to 0. Sin 0, 0. So velocity graph is 0.
Yes.
Can I do it in green color?
Yes.
0. At a 90, sin 90 is 1. It will be plus minus a omega. It's becoming minus a omega. Correct? Yeah? You understand? At 0, it goes here, then goes here, then goes here, and then goes here. Are you clear? This is plus a omega, maximum amplitude. Okay, so let's continue for acceleration. Acceleration time graph. You know, minus a omega square cos omega t. Write that. A is equal to minus a omega square cos omega t. At 0, cos 0, cos omega, a omega square, minus a omega square. Let me do it in different color. Minus a omega square is amplitude. Then it gets to 0, it gets to maximum, which is plus a omega square, and then goes to 0. You understand? And then goes here. Can you see? This is a cos graph, this is a sine graph, and this is a cos graph. And you understand from here that displacement is lagging behind velocity. Velocity is ahead of the displacement by pi by 2. Acceleration is ahead of the velocity by another pi by 2.
Yes.
So these things, are you clear? Acceleration is ahead of the velocity by pi by 2.
Yes.
Correct? Velocity is ahead of the displacement by pi by 2. Are you clear? So this is one explanation to understand how a phase relation, you are able to see how it's one is lagging behind other or one is ahead of the other.
Yes.
So now we will think, okay, displacement starts at one point, so then acceleration should start at that point. It's not there. Can you see? It's starting at different point, and there is a phase difference. So this clearly explains the phase relationship between a displacement, a velocity, and an acceleration. Are you clear? So they ask you this is what you should do, a phase relationship. The question is phase relationship between displacement, velocity, and acceleration. So next is I did some numericals after this, and that's all. I did some numericals after this, and that's all. But what are those? What is that numerical? I have to see. 1 second. Hold on. So there is this repeated question which is asked in all entrance exams. Okay, so then that is x is equal to. Okay, I think I have to surf the net for the question. This question, which is repeatedly coming for everyone's school exam, board exam, entrance exam, plot the corresponding reference circle for each of the following simple harmonic motion. Indicate the initial position t is equal to 0 for the particle, the radius of the circle, and the angular speed of the rotational particle. For simplicity, the sense of rotation may be fixed to be anticlockwise in every case. Okay, so let's look at this question. X is equal to minus 2 sine 3t plus pi by 3. Pi by 3 means you know 60 degree.
Yes.
Okay. This will be omega t plus phi naught Marier. Correct?
Yes.
You don't want it as sine. Displacement, according to us, we have learnt as in terms of x is equal to a cos omega t plus phi naught. Correct?
Yes.
So we prefer it as x is equal to a cos omega t plus phi naught. This is the way we will write displacement for us to be able to evaluate things. So how to convert this into a cos? You have to remove the negative sign. So I told you can write as 90 plus.
Yes.
So x is equal to 2 into cos of 90 plus 3t plus pi by 3. When I write that, a 90 plus will become, it's odd integral, so it will become sine. Second quadrant, pi by 2 plus means it will have a negative sign. You can verify what you've written is correct going in reverse. So then therefore, x is equal to 2 into cos of, let's write 3t first and write pi by 2 plus pi by 3 together. Because like omega t plus phi naught, we are going to get the phase difference. X is equal to 2 cos 3t plus, this is 6 LCM into 3 into 2, which will make it 5 pi by 6. So can you see that x is equal to 2 cos omega t plus phi naught. We got it in the form x is equal to a cos omega t plus phi naught. Therefore, you know the amplitude is 2. You know omega itself is 3. When omega itself is 3, omega itself is 2 pi by capital T itself is 3. So time period therefore is 2 pi by 3. You can calculate the time period seconds. You understand? Like that and all, you can write your answer. Yes? Yeah, so then therefore omega is equal to 3 shows that 2 pi by capital T is equal to 3 and T is equal to 2 pi by 3 seconds, correct? And then what else? You know phi naught, which is the phase difference itself, is 5 pi by 6. Okay, we got all this. Okay. So when what you do is you substitute T is equal to 0 here. What will happen to this equation? X is equal to 2 into cos of T is 0 means cos 5 pi by 6. Which is 2 into cos of, what is 5 pi by 6? Is pi minus pi by 6.
Yes.
Yeah? And pi minus means it will come in the second quadrant where only sign is positive. This is cos. This is even integral. So it will be 2 cos pi by 6 with a negative sign. What is cos 30? Pi by 6 is 30. Cos 30 is root 3 by 2. So minus 2 by root 3 is the solution for this. So at a time t is equal to 0, you understand that it is negative. The position is negative. So in a rotational motion, if you have to depict this, you know that x is negative, so it can be either here or here.
Yes.
That's when it will be x will be minus 2 by root 3. So we don't know whether it's on the top or at the bottom. But look at the phase difference, it's 5 pi by 6. This is called 5 pi by 6, which the angle it makes with the x-axis. So if it has to make a 5 pi by 6 with x-axis, it is going in, they said it's given in anti-clockwise direction. Anti-clockwise means we start from here and go like this. Don't you think 5 pi by 6 is actually pi minus pi by 6, right?
Yes.
Which will be just here. Yeah? So let me check if my answer is correct. 1 second, hold on. Yeah. So therefore, you know this is what is a 5 pi by 6. Correct? So whatever it is, the degrees also you can write if you want. So you understood how to put this. This is the point. This is the point. At a time t is equal to 0, where is it? Correct? At a time t is equal to 0, this is where the point is.
Yes.
At a phase difference of 5 pi by 6. So I hope you understood. Okay, 1 second, hold on. Is that what he has written? Let me check. 150 degree radians per second. So omega is 3 radians per second. Omega is 3 radians per second.
Phase is 5 pi by 6.
The equation is completed with a simple harmonic equation. Can you see we got a simple harmonic equation like this, with which you could understand what is your amplitude, what is your phase difference and everything, correct? Okay, so that completes the first sum. Time period is also something we got. Everything is right. So next question is x is equal to cos pi by 6 minus t. You want x is equal to a cos, a is 1.
Yes.
That's why it is, so no problem for me. A cos omega t minus phi in varna. Do you know cos of minus, you should know one thing, cos of minus theta is cos theta, whereas sin of minus theta is minus sin theta. So if I switch this, I'll get a cos of minus theta, which will anyway be cos theta. So I can switch it. I'm allowed to switch this. So I can directly write this as x is equal to cos of t minus pi by 6.
Okay.
Because cos of minus theta anyway is cos theta, so it doesn't matter. So cos of t minus pi by 6, which is like x is equal to a cos omega t minus phi naught. What is the place of a? Is 1 amplitude, 1 meter or centimeter, whatever. If they ask you for amplitude, centimeter, x is in centimeter, they have given. So x is equal to 1 centimeter. Here also I should write amplitude to be 2 centimeter. Yeah. So you found the amplitude from there. What is omega? Omega, here you have 1 radians per second. Because what is the place of omega is just 1. And then for a time period, you know, omega is equal to 2 pi by capital T, which itself is 1. So time period is equal to 2 pi. Thus you get 2 pi seconds to be the time period. Correct? So you got radians. This is radians per second. Omega is 1 radian per second. What else you want? You know phi naught. Okay. You know phi naught itself is 5 by 6. Initial phase difference itself is pi by 6. So minus pi by 6. Can you see it's negative?
Oh, yeah.
Normally it's omega t plus phi naught. Sorry. The usual equation, simple harmonic motion, is omega t plus phi naught. So phi naught becomes minus pi by 6. So you got all this. You put time t is equal to 0 here. Put time t is equal to 0. You get x is equal to cos of minus pi by 6. Cos of minus theta anyway is cos theta. Cos pi by 6 itself is cos 30. Cos 30 is nothing but root 3 by 2. Therefore, a position is positive. Therefore, in a circular motion, if I'm going to depict it, I know it's either here or here.
Yes.
Because the x is positive. And angle is minus pi by 6. When the angle is minus pi by 6, it's got to be here. So that because this angle only, when you measure like this, it will be minus pi by 6. When you measure like this, it will be a larger angle. This is the way you are supposed to measure. You are supposed to measure it only anti-clockwise. The measurements are always, when you keep a protractor, you measure like this.
Yes.
But this is clockwise. I am changing the direction. Therefore, it will be minus pi by 6. Are you clear? Let me check if my answer is correct. 1 second. Yeah. So that's the position. That's a wrong thing. That shouldn't be there. So let's go to next question. Next question is x is equal to 3 sine 2 pi t plus pi by 4. Correct? So this is like omega t plus pi by 4. Yeah. So then x is equal to 3 sine omega t plus pi by 4. What we need is a cos omega t plus phi naught. So to convert the sine into you have to write it in terms of cos.
Yes.
Normally you put 90 plus,
Yes.
but there's no negative sign here.
Yes.
If you put 90 plus, you will get a negative sign. So you can't put a 90 plus. So probably you have to think of something else. But it has to be, if I'm writing it as cos, it has to be odd. That is when cos will become sine. So I can't write 90 plus. Okay, so what are the odd integral? 90 plus I can't write. Can I write 270? Yeah, 270 minus all school torture children. I'll still get a negative sign. Correct? Because third quadrant also is definitely negative. I should not get a negative sign. So then I have to write, I cannot avoid. I cannot do that. You understand? So then what I can do is still keep the, you can introduce a negative sign and write it as cos.
Okay.
Minus 3 cos. You understand? So I can write 90 plus now.
Yes.
I can write a 90 plus, yeah. 90 plus now. A pi by 4 plus 2 pi t. Now go in reverse and see. Okay, so let me stick to 90 plus only all the time. So then I'm keeping a negative sign because a cos 90 odd integral becomes sine. And a 90 plus in the second quadrant should give me a negative answer. So when I write as cos 90 plus, I should also write minus there. You agree with me?
Yes.
You understood? So now I've managed to convert the way I want with a 90 plus, but inserted a negative sign. So then x is equal to minus 3 cos 2 pi t is the omega t. Let's write it first. Plus a pi by 2 plus pi by 4, LCM is 4 into 2. 2 pi plus pi is 3 pi by 4. This is like x is equal to a cos omega t plus pi by 4. Can you see? But only thing is, I'm getting an amplitude which is negative. But doesn't matter, the amplitude can be above and below a plus 3 or a minus 3, it doesn't matter. So you can say the magnitude of the amplitude is just 3 centimeter. Correct? You don't have to worry about that. But the angle, what did I write? Yeah, pi, this is phi naught, not pi by 4. So you know what is in the place of omega? Omega itself is 2 pi radians per second. And omega itself is 2 pi by capital T, which itself is equal to 2 pi. So T is equal to 1 second. And phi naught itself is 3 pi by 4. All this we have. Correct? So now how to do this? Put T is equal to 0 in this. So x is equal to minus 3 cos t is equal to 0 means cos 0 is 1. T is equal to 0, okay, t is equal to 0 means it becomes cos 3 pi by 4, sorry, cos 3 pi by 4. When I put t is equal to 0, t 0 plus 3 pi by 4 is cos 3 pi by 4. So x is equal to minus 3 into cos pi minus pi by 4. Even integral.
Yes.
Second quadrant, so it has got to be minus of my even integral cos pi by 4 And second quadrant another negative. So it will be plus 3 cos pi by 4. So it will be x is equal to 3 by root 2 is the amplitude I get. Therefore I know it's got to be in some positive position. Either there or here.
Yes.
Okay, now look at this angle which is 3 pi by 4. 3 pi by 4 It's not negative. 1 second. X, what is x here? Yeah, what I'm writing is right. Can you see here? It's got to be only here. Yeah, but the angle you say 3 pi by 4. But this 3 pi by 4 is here with this x-axis. Not with this x-axis. You only need an angle with the x-axis. It can be here or there. So then that's okay. Since we used 90 plus, when we were doing the other day, I used 270. You remember, I did the sum using 270 minus. That is also possible. So I can do the same sum using 270 minus. You wanted me to show you? No. Are you clear with this? It's too much information, right? So last sum is x is equal to 2 cos pi t. But you will think this is positive. And yes, I have arrived at a positive value.
Yes.
But you will think 3 pi by 2 is pi minus pi by 4. Should it be second quadrant? It can't be second quadrant because x itself is positive. So you have to locate that angle with this x-axis, which will be 3 pi by 4. Are you clear?
Yes.
Okay. It is not minus 3 pi by 4 because I am still measuring it in the anti-clockwise direction. So then let's do x is equal to 2 cos pi t. Okay, 2 cos pi t means omega t plus phi naught is not even there. Okay, you need x is equal to a cos omega t plus phi naught. It's already in the same format only, where phi naught itself is 0. Can you see?
Yes.
So you put t is equal to 0 here, you get cos 2. Because cos 0 is 1, so x is equal to 2, sorry. So the fact that x is equal to 2 shows that it has to be only here.
Yes.
And the fact that phi is 0 shows that this point itself is only here at a time t is equal to 0. Are you clear?
Yes.
So these are the sums I dealt with on that day. We may have to do some more sums. Did I do anything after this? No. So we'll stop with this and we'll continue in the next video, okay?